All right, so continuing our transformation notes, we're going to actually move specific objects in specific ways. And for each one of these problems, there's multiple to do, so I'm just going to do one really quickly, leaving you the rest for your homework. So you'll be doing 1A, which says apply this transformation. So this transformation is over 1, 2, 3, 4, and up 2. So it's, this line, but that line goes over. So from here, 1, 2, 3, 4, up 2. 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 And I think those were all of our pieces. And so now, if I were to connect them, I would get the exact same shape where all pieces have moved over, all points have moved over 4 and up 2. And they have all moved in the correct direction and hopefully the correct amount. All right, this one, it says reflect these shapes across the x-axis and the y-axis, and there's 4 of them. I'm just going to choose one of them and reflect across the x-axis. So we'll just reflect this across the x-axis, which says if I were to take any line up to here, that is 3 units up, the reflection must come 3 units down. Now, this next one's 3 units up. The reflection must come 3 units down. This point is 4 units up. It must come 4 units down. This one is 1, 2, 3, 4, 5, 6 units up. The reflection must come 1, 2, 3, 4, 5, 6 units down. And piece by piece, this point is 1, 2, 3, 4, 5 units up. It must come 5 units down. This is 6 units up. It must come 6 units down. This is 5 units up. It must come 5 units down. And then I got to connect these pieces in the same way they were connected before, which looks like this, and then out to here, and then back to here, then up to here, and over to here, and back down to here. And so this shape should look identical to this shape, just reflected across the x-axis. The x-axis is our line of symmetry. So there's 4 shapes here, and you are there and going to draw a reflection of each across the x-axis and the y-axis. But to do the rest of those is your homework. These are rotational symmetries. So these first ones are rotate 180 degrees about the origin, which is the center, and these are rotate 90 degrees. So let's just take one of these, say this little one right here, and if I wanted to rotate this 180 degrees, that would say this line is going to get rotated 180 degrees over to this line. So if this thing was 2 up, it now becomes 2 down. If this was up 2 over 2, it would be down 2, left 2. If this was up 1 over 2, it would be down 1, left 2. So it's a lot of dots in there, but it should look like this, where at any point I've rotated 180 degrees around the center point. Now, for a 90-degree rotation, we can do something similar. So it'd be, let's take this shape, rotate it 90 degrees. So everything that isn't oriented to that line will now become oriented to this line. If this point was right 2 up 1, it would go up 2 left 1, right? So whatever happening here should now happen here, 90-degree rotation. If this is 1, 2, 3, 4, up 2, it should now go up 4, left 2, 90-degree rotation. If this is right 2, up 2, it should go up 2, right 2. If this was what? Right 1, up 3, it should go up 1, left 3. And we can start to put these things together. Let's see, I'm missing one other point, which is this one, which was 1, 2, 3, 1, 2, 3, 4. So it should go up 3, left 1, 2, 3, 4. Now if I connect all of these lines, we should get the exact same shape, but rotated 90 degrees around the origin. So just a slightly different orientation. All right, this is not homework. It just says which is the transformation. Just for practice, I'm not going to have you guys do this, but this would have, again, reflectional symmetry. This would be rotational symmetry. This looks like it would be rotational symmetry about some point over here. And this, again, looks like reflectional symmetry. This thing says what's wrong with this, and this does not represent a translation because translation goes point to point. So this would have to go from here to here, or from here to here. So that notation is wrong because you're going from the top left to the bottom left, so you're not connecting correct points. All right, so the homework is those ones that I just went over, and these questions right here. Number 2, 3, and 4. It just says discuss the symmetries. And so there's two kinds. You need to mention the how many lines of symmetry and how many fold rotation. So for example, this first one has one line of symmetry. And it also is a two-fold rotational object. If you rotate it 180 degrees, it will look the same. Number 2, design 2 has no lines of symmetry, right? If you were to do this, there is no left side is the same as the right side or top is the same as the bottom. However, it does have rotational symmetry because if you rotate this up to here, it looks the same. So there's 1, 2, 3, 4, 5, 6. So this would have 6-fold rotational symmetry, but no lines of symmetry. If I were to look at design 3, if I were to put a line here, the top left is the same as the bottom right. So there's 1 reflectional line of symmetry, 2, 3 reflectional lines of symmetry, plus I could also cut it here. There's another reflectional line of symmetry and another reflectional line of symmetry and another reflectional line of symmetry. So some of these objects have lots of symmetry. So again, these questions, numbers 2, 3, and 4, they just say look at these 6 shapes and say how many lines of symmetry they have and what is their rotational symmetry. And that's it for transformations.